New data arrived in my spreadsheet. I need to figure out where to drag and drop my formulas again. Is there a better way to do it?
You can use the array formula.
Array what? It sounds complicated to me. I've heard about arrays learning computer science at school like 20 years ago, and I haven't made it.
Look, it's super easy, and you can stop dragging the formulas down forever. I'll show you how, follow me. But now, go subscribe to the owoxbi YouTube channel where I place useful Google Sheet hacks. Hey there, I'm Yevgen. On this channel, we speak all things about analytics, marketing, spreadsheets, and data manipulation. I'm here to make your data work for you. And today, I'll walk you through multiple array formula examples that really simplify the life of every spreadsheet user, no matter you are a data professional, project manager, marketer just like I am, a C-level, or a business owner. So, buckle up, grab your data, and let's fill your data set with tons of calculations in seconds. You might be wondering, what exactly is that array formula? Well, think of it like a super formula in Google Sheets. It's quite unique though. It lets you apply the same operation across multiple rows or even an entire column without having to copy and paste or drag and drop your formula down every single cell. It's like giving a single command to an entire list of rows at once. Now, why should you use array formula instead of the other formulas? So, let's break it down. Number 1. Efficiency at scale. Imagine you have got thousands or even tens of thousands of rows of sales data. Google Sheets allows you to store like 10 million cells. Updating each row with an individual formula isn't just time-consuming, it's prone to errors. With array formula, you set it up once, and it runs through the entire table like wildfire, updating instantly as new data comes in. Look, spreadsheets are absolutely irreplaceable for data analytics and business of any size. I'll leave a link to another video on this channel about the corporate reporting in spreadsheets in the description down below, or you can watch it right here. Reason number 2. Clean sheets. Nobody likes messy spreadsheets, right? Using separate formulas for each row can clutter your worksheet fast. Array formula helps you keep your sheets clean and organized by consolidating those hundreds of formulas into just one line. It's not just neat, in fact, it makes your spreadsheet faster and more efficient. Reason number 3. Dynamic data handling. Array formula reacts dynamically as your data changes. Add new sales record or project data, changing a pack of existing rows, array formula automatically adjusts without skipping a bit. And all of those calculations are going to be available inside your pivots or charts you built when you open the document. You won't need to add formulas again and again. So, if you are managing budgets, overseeing marketing campaigns, or tracking project timelines in Google Sheets, basically no matter what you do in terms of business analytics or business data, incorporating array formula into your spreadsheet will not only save you a shit ton of time, but also give you a clearer, more accurate picture of your data at a glance. Now let's break down the syntax and how array formula works. I'll show you all of the possible examples, like 10 or more of those, in just a minute, but now let's just look how to get started, and it's pretty straightforward. The syntax looks like this: array formula plus some calculations in parentheses. Think of array formula as a big umbrella covering all the cells you specify, applying the same kind of formula to each one automatically.
Let's see it in action. Let's take a simple example where we want to multiply two columns of numbers to calculate totals. We have a product list where column B contains the quantity and column C the unit price. To calculate the total price for each item without having to drag and drop the formula down each row, we would use the array formula. And here's how you set it up in Google Sheets. To multiply these two columns and output the result in column E, you would enter the following formula in cell E3. Just like that, Google Sheet fills out the entire column E with the product of corresponding cells in column B and C. No dragging required, no filling down, and no room for drag errors. This method allows you to perform calculations over a range of cells, as you can see in the output on your screen right now. Each cell in column E now displays the total sales amount for each item, calculated automatically from each row's quantity of units sold and price. It's pretty slick, right? But this is just the beginning. With array formula, you can go far beyond the simple things here.
Suppose more data arrives, and you need to expand your array formula to handle new entries dynamically.
But instead of limiting your range to B11 and C11, as you can see on the screen right here, let's adjust it to cover entire columns. So we'll do it like this. Let's press Enter, and we have a problem here. Expanding to full columns can introduce those zeros in the output cells, where there are no corresponding values in the columns B and C. This clutters your results with nulls or zeros, which might not be desirable for you. To ensure your data stays clean and your report accurate, especially when you are dealing with ranges that include empty cells, you can modify your array formula to ignore those blanks. Let's add an if statement here to check whether the value in column B exists. So if B3 to B is not blank, then we have the value over here. Otherwise, it's blank. Just once again, our if statement that checks if column B is not empty for a given row. If column B contains data, it performs the calculation of an array formula. Otherwise, it leaves it blank.
Let's also discuss how to ensure errors are managed effectively within your array formula.
For example, let's add text here instead of the numeric value, and then we'll see an error here. Now, we can use the if error to handle this. Let's add the if error formula with just two values inside our array formula. So the statement and then our error message here in double quotes. This adjusted formula ensures that any errors in calculations will display the word check, prompting you to review the inputs without affecting the cleanliness of your data.
Great. Next, in Google Sheets, there is a common need to merge text from different columns to create a single one. This is especially handy when dealing with data like campaign names in marketing or user details, or any scenario where you want to work with present text data differently. Suppose you are tracking various marketing campaigns in a spreadsheet, and we want to create a consolidated description for each campaign.
In the column B, there is a type of campaign like email or social media, and column C contains the specific campaign. To create a full campaign description in a new column, you can use array formula to combine these text fields with a dash in between. This makes data organization much more manageable. So to concatenate the campaign type and name, we will place this formula in the column where you want to combine text to appear. So B3 to B12, ampersand, our dash with two spaces and double quotes, then ampersand again, and C3 to C12. Here we go. This formula tells Google Sheets to take each entry in column B and column C, put a dash between them, a couple of spaces, and output the result in the column E. As a result, each cell in column E will now display a combined description of the campaign type and name like email, campaign A, social media, campaign B, PPC, campaign C, and so forth. Let's also expand our ranges and add an if statement to clear the null values. This fill-in ensures that no matter how many entries you would add to columns B and C in the future, column E will always update it to reflect the latest data.
Moving on. Let's explore how array formula can significantly simplify operations involving matrix data structures. This is particularly useful in scenarios like calculating commissions, sales totals, or any situation where you need to multiply corresponding elements from two matrices, or arrays, just like the array formula. Imagine you manage sales data across different regions and need to calculate the total commission based on sales figures and commission rates.
So we have two matrices here. One matrix containing sales data from different regions in cells B4 to C5. Another matrix has commission rates corresponding to those regions in D4 to E5. We can use array formula to multiply these two matrices together, providing a quick and efficient method to calculate total commissions. And here is how we set up the array formula to handle this. We'll use an array formula, then specify B4 to C5, multiply by D4 to E5. The result will be a new matrix where each cell contains the product of the corresponding sales amount and commission rate.
This method is particularly useful in financial modeling, budgeting, or any analytical task that requires multiplication of arrays to get meaningful insights. Now, let's see how to use array formula with nested if statements for more complex conditional operations. Suppose we want to calculate bonuses for our employees based on their sales performance. The criteria for the bonuses are as follows. If an employee's sales exceed 1,000, they receive a 10% bonus. If sales are between 500 and 1,000, the bonus is 5%. Otherwise, no bonus is awarded. This type of calculation involves multiple conditions and is perfect for using array formula with nested if statements within it.
Let's start with an if formula and then we'll wrap it with the array formula. So first things first, if C3 is greater than 1000 or equals, then our bonus would be C3 multiplied by 0.1 or 10%. Otherwise, we need an if statement again. If C3 is greater or equals than 500, then our bonus is the value in C3 multiplied by 0.05, which is 5%. Otherwise, it's 0. Let's check whether it works or not. Great. Now let's add the ranges here and wrap it up with an array formula. The output of this array formula will update in the column where it's applied, instantly reflected the calculated bonuses based on the sales figures in column C. Basically, you know how to change the ranges to the whole column and take care of the null values.
Let's dive into a scenario where you need to drag and drop the result of the SUMIF function. Imagine we are tasked with analyzing the effectiveness of various marketing campaigns.
Our spreadsheet here contains data on the revenue generated by different marketing campaigns. Column E lists the revenue. Column B, campaign name. Column C indicates the region. Column D shows our spending, and column F specifies the quarter of the year. We want to specifically focus on the revenue generated from the campaigns in North America. Let's do it. We'll use the SUMIF formula first. Whereas our search range is C3 to C16, then our criterion, which is North America in double quotes, and then the sum range, E3 to E16. Great, so we don't need an array formula here yet. But what if we want to use a few conditions here instead of just one, which is North America? Like for example, instead of filtering by region, we'd apply a quarter here in addition to the region. Let's assume we need only the campaigns from North America in Q2. And here is how we would do it here. We would add the values from the column F here with an ampersand sign to the search range. And then we will add Q2 in double quotes to the criterion and wrap this with an array formula. Great. So our only campaign from North America in Q2 was the email B campaign. with a revenue of 7 grand.
Sorry for showing the marketing example all the time. That's just because I'm the marketer. And that's because I see those reports all the time. This way of using array formula basically simplified a lot of things. As instead of using the text values here, you can reference another cell to quickly calculate the matrix you need through the whole list of data. Plus, it really updates as the data changes. But this way of using array formula with SUMIF for multiple criteria is limited. You can use it just for the same types of criteria like match. But what if you have multiple criteria that are different? You can incorporate the SUMIFS with then array formula.
In our table, we have the units sold, the sales amount, and the prices per unit. Let's say we need to sum sales amounts for products within a specific price range. For example, below 20 and with a minimum sales quantity of, let's say, 10. Here is how we would do it. So SUMIFS, our sales amount goes here, so C3 to C11. Then we need to check whether the values in the range of B3 to B11 are greater than 10, plus our price column, so D3 to D11 should be less or equal than 20. And we'll wrap this all with an array formula. Again, this is used to process the entire range as an array, since SUMIFS, like SUMIF, doesn't natively handle arrays. This setup is perfect when dealing with large datasets and complex conditions, streamlining the process and ensuring your Google Sheets remain clean and efficient.
One more example. Suppose you have a sales dataset for different regions and need to determine which products were the most popular in each region. This involves counting how many times each product appears in the sales records for each region.
So we have our sales data here. Count C lists the products sold in region 1. Column B represents the date where the products were sold. It could be order ID, basically anything. So we want to find out the number of orders for each product here. To list all of the products, we will use the unique function. So we will apply it to the whole range to list all of the products we've been selling in this specific time frame. Great, we have the product A here, product B here, and product C here. Then we will apply a COUNTIF function with an array formula to get the count of sales all at once. Amazing! Now we know which products are sold at which number.
So this combination of functions, COUNTIF and array formula, is good when it comes to just one condition. But when you need more, it's time to use the COUNTIFS function. And I'm not going to actually show this today, but I'm going to cover it in details when we're going to be speaking in another video about the COUNTIFS function separately. So make sure you subscribe to this channel and enable notifications so you don't miss that video out. Troubleshooting common array formula errors in Google Sheets. When working with array formula in Google Sheets, you might encounter several common errors. Here's how to troubleshoot and fix this effectively to ensure your formulas work seamlessly. Number 1. Break down complex formulas. If your array formula is giving you an error, try breaking it down into smaller parts. This approach helps isolate and identify the specific part of the formula causing issues. Number 2. Checking data types. Make sure that the data types, text, numbers, dates in your formula match what's expected. Mismatch can lead to errors or unexpected results. Number 3. Review cell preferences. Double-check that all cell references are correct and pinpoint to the intended cells containing the expected data. And always try to use fixed ranges such as A to C, so it's always clear. Number 4. Num error. It's pretty common in scenarios involving improper numerical operations like division by zero or invalid inputs. The solution would be to implement safeguards such as using if statements to avoid dividing by zero and ensuring inputs are valid for the operations they are used in. Functions like if_error or is_error can help manage and replace error with predefined actions or values. Number 5. NA error is typically seen in lookup functions when a result cannot be found. The solution is to check the accuracy of your lookup values and range references. Use if_error around the lookup function to provide a default result or message if no match is found. By applying these troubleshooting steps, you will be able to maintain robust and error-free spreadsheets, leading to more reliable data analysis and calculations. And there you have it. Today we've dived deep into the world of array formula in Google Sheets. It's powerful, it's simple for your data management tasks. And look, it was not as complex as you thought it would be at the beginning. We've discussed the syntax, the setup, the basic arithmetic operations, matrix manipulations, then moved through various practical applications of using array formula with functions like if, COUNTIF, SUMIF, and so on to handle real-world analytics and tasks efficiently. Now, I encourage you to download the practical Google Sheet template linked in the description to this video. It is preloaded with examples we discussed today. This is a fantastic way to practice and master array formula yourself on your own. And if you found this video helpful, please give me a thumbs up and consider subscribing to our channel for more tips and tricks on Google Sheets and analytics. Hit that notification bell so you never miss our new content that could enhance your data handling capabilities. Thanks so much for watching this video. I'm Yevgen from Owox, and remember, mastering Google Sheets or Excel is about making smarter decisions based on your business data. So keep spreadsheeting, stay data curious, and as always, happy analyzing!